All right, hello everyone. So I have my NVIDIA Nano right here, and we're gonna start firing it up and start learning more about AI. That's our goal, is to understand how does AI, how do these LLMs actually use tools? How do you orchestrate all of this? How does uh, Google or OpenAI, how do these different companies interact from the user to their service to the LLM? That's what we're trying to investigate, is how does AI actually work? So let me power this one up and we will plug it in to our computer and start going. Okay, there we go. I'll plug it in and wait for it to boot. Okay, so I will minimize this. And now in the last video, what we were doing is I got this response from Olama, and it says the entire response which it gave, right? But then it also gave all of this like context thing, and then some statistics about like how long the evaluation took, like this many whatever like microseconds, eval count, right? All of these different uh, statistics, like the total duration that it took, the load duration, which is like how long it took to load into RAM, the prompt evaluation. I believe these are, let's see, or count. This is the number of tokens, I think. So what I want to do is I want to come in here and I'm going to try to figure out what is this context. So for the context section, how is it useful for me? And is each of those numbers a token which was part of my input and my output? Okay. So what are some of the other things that I want to do? After we do this, it's time to actually start going into writing Python code for it. So let's ask this question, and I think that my Pi should be not my Pi, my Nano. There we go. Should be up by now. Yep. All right. And let me come to FileZilla. I know that we're going to need to be putting this stuff in. So host, is that me? I don't know. Username is either Timothy or Jetson. I don't know which one's the. Can you. Okay, obviously that's not it. Port 22. I don't know if this is going to work. Could not parse server address. Localhost. I don't know. I always just use WinSCP. What port previous connection? Okay. Connecting to localhost. Let's see. Okay, maybe FileZilla doesn't work. I don't know. Never used FileZilla before. I always just use WinSCP. Nope, apparently it doesn't work. I'm not sure. Stop. Yes. Okay. I should have put that in my thing here. All right. So let's just come in here and the power of context field. The context array is your save game file. Okay. What? Save game file. As we discussed, LLMs are stateless math equations. If you want a model to remember, oh my goodness, a conversation, you have to send the previous messages back to it. However, sending raw text every time is insufficient because the GPU has to recalculate the math for that text from scratch. Okay, how it's used. Oh, I see. So it's a way to grab the memory and make it where the LLM does not need to recalculate it. Okay, that makes sense. So when you receive a context array from Ollama, you are receiving the numerical state of the model after it finished your last prompt. Okay? If you send this array back in your next curl or Python request, Ollama doesn't have to reread the whole conversation. It can jump directly to where you left off. This saves massive amounts of prompt evaluation time. Okay, that makes sense now. Each number is indeed a token. Think of the model as having a massive internal dictionary, usually 32,000 or 100 or 128 words. So that's kind of how. Hold on, I'm actually kind of curious. Can it do Chinese? Google Translate. Okay, we want Chinese. Okay. Okay, here. 你会说普通话吗? Okay. Here we go. Now, Ollama run llama 3 8 billion. Go. It's going to not pull the manifest, but load. So this is that thing that takes like 60 seconds because it's loading it from our SD card into RAM. So this will take a little while, and then we can paste in this. I'm just curious, can it also does it have Chinese in these like tokens? Where was I here? Okay. So the might be associated with 450. Okay, Apple might be 7,821. Exclamation might be 15. Okay. The context array you see here contains the entire conversation history, both the input and the output of the AI converted into these dictionary numbers. Okay. Does the time to first token apply to Python chat? Wait, did I ask that question? Whatever. Yes, whether you use the... I don't think I asked that question. Because we already know the answer that it does. Alright, I wish that this would load. And while this is loading, I am on a Mac and using FileZilla to transfer files onto my my Nano, but I don't. Okay, so how can I connect? Okay, there we go. Open, yeah, site manager. Okay, new site. In the protocol, so that should be port 22, right? It should, whatever. Let's just follow this exactly. Okay, here we go. This is loaded up. Now I want to paste in this, and let's see. 我可以尝试说普通话，虽然我是一个人，虽然我是一个人工智能模型应该是，我也想学习了普通话的基本语法和词汇，可以与你进行 简单的交流应该是。请注意，我可以不会像 native speaker 母语应该是可以养六，不知道，我不会直立说处理能力理解的普通话没有，我觉得你是比我更厉害的。如果你想聊什么或者有任何问题，请随时说出。Okay, so it can. All right, that's cool. That's cool. So I didn't know native speaker, right? And so it was saying that, so it's saying I can try. Although I'm just an AI, I want to learn Chinese grammar and vocabulary. 可以 like we can talk Chinese in simple conversation. But be careful, I am not a native speaker. This one I'm not quite too sure. Yeah, I don't know this one right there. Yeah. Anyways, something here. And then if you have anything that you want to talk about, just ask. Okay. So it can. That's awesome. All right. So let's go back to FileZilla. Here. Okay. And what are we going to do? We need new session or something. Where is that? No idea. Guess we just ran a site manager. Okay, site manager. There we go. Click on new site. Okay. Give it a name. Okay. Doesn't say anything for name. So, oh, rename. Here we go. Rename. Jetson Nano. Okay. Awesome. I love that. Oh, okay. There we go. Okay. In protocol, yeah, we want SSH, right? SFTP, SSH, file transfer protocol. Okay, that makes sense to me. In host field, yes. Enter the IP address of your Jetson. Oh, okay, so this is the IP address of my Jetson, which will be here. Okay. No wonder it wasn't connecting. Okay. Okay, so this one is going to be oh, come on. Okay, there we go. Timothy at jetson.local, right? So I'm just gonna confirm all of this though. Okay, so we do that. IP address should be there. The username, the same credentials as you logged in via the terminal. I believe this one would just be again and then Jetson, right? Okay. So login type. Do we see login type? Do I need to specify the port too? It should automatically do it, right? Okay. Login type. So one of these? No. Advanced. Huh. Okay. And then connect. Okay, so I'm gonna, by default, you'll be logged into this. Okay. Here is how I did the SSH from my terminal. What should the fields be? Okay. I just want to make sure that I'm... It doesn't work. I don't know. Google is having a little bit of problems with Gemini. First they like deleted all of the history, so I lost all my conversations. And now when I press enter, it doesn't even send it to the Google servers. And I'm like, okay. All right. Okay, so yeah, IP address is after the @ sign. Okay. Yep. IP address is... Okay. Should I just do Jetson @ local? Can I do that? Like, host is going to be Jetson @ local, and then Timothy, or Jetson.local. Let's see. Allow, yeah. What's this? Your always trust this host. Okay. Okay. Oh, we logged in. We logged in. Okay. So now what we want to do is, obviously unfamiliar with this specific format, but in like WinSCP, all you have to do is like copy things over. So which one is my like normal? I don't need this anymore. Where am I here? Desktop. So this seems like it is inside of my Jetson. Okay, then where is my system, users, library, users, me? Allow? Allow? Okay. That's not... We want like... Do we see desktop here? No. Okay. We are going to do new window. PWD. Users Timothy Grant. Okay. So we should be able to do that here, right? Do we see users Timothy Grant? Yes. Now I should see desktop though. Okay, so apparently it probably has a lot of hidden files. ls-la. Okay. Okay, so okay, there. That makes sense. Okay, here we go. Here we go. Here we go. Okay. And then practice agentic AI. Here we go. Okay, so I want to essentially transfer over this to my Jetson, and I can get rid of this now, I think. Okay, So now I want to transfer this over to my Jetson. So we're going to do exit here. No. Okay, so home and Timothy. All right, so we're going to go one file up. We're just going to do it. Go one file up. Here we go. Okay. Is this really where I want to run my code? Possibly. Possibly. Can I just do this? Is it gonna add it to that? Folder? Or can I just drop it into the file that I'm already in? I don't know. This is just... Okay. So now, do we get it? Yeah, so there's Agentic AI. So let me go into that. Okay, and then ls, and then I have some like Python examples. So let me just try Python 3 example1.py. Let's just see if it, okay, no. Oh, right, because we have Ollama as an executable, but not as a library, right? Okay, so that's awesome. Now we need to go figure that out. Okay. Well, I can... Okay, so I am attempting to run a Python script in my Nano, but am getting the Ollama. Because I remember this one is kind of weird, because if you do like apt install Ollama or something, I believe you get an error. But I mean, we can try it before we do it. Oh. Yeah, see, there we go. Unable to locate the package. Let's just try snap install Ollama. Okay, sudo snap install. Yeah, see, exactly. As a library, right? Okay. Yeah, apt install can't find it because it's not part of the official Ubuntu repositories. Okay, snap. You should avoid it. Okay, yeah, that makes sense. It's context canceled. Okay. Pip install. Okay. Okay, let's try pip install. So then we need to install Python pip. Oh, okay. So, and then we'll go and try to understand kind of why it failed and just get a general idea. Okay, so sudo apt install Python 3 pip, right? Here. And then after, yes, we want it. And then after this, we will do pip install Ollama. All right. Come on. You got this. There we go. Pip install Ollama. Ah, this looks better. Ah, I like the look of this. I like the look of this. Okay, and then we'll try to rerun our project. Okay, so now Python 3 example1.py. Let's just see if it runs. Okay. Oh, right, Quinn is not, we didn't download Quinn yet. So we need to go into example1, right? And we need to change the model. So let me just look at what we have, right? So we have this function, which is like a tool. It's called get RAM usage. And then I have like essentially this is a pointer to the function, right? And then messages is going to be kind of like the appending that list. And so I'm going to go back over this and try to, that's kind of what we're trying to do with this entire project, is understand how this works and make it more and more complex. But right now I'm just trying to get something that runs. So instead of Quinn, we don't want Quinn. We want llama 3 8 billion, right? And now we, okay. Now we want to run this again, and hopefully this will work. Okay. I should have looked at what the file said. Oh, I have it up here. Hold on a second. Agentic example1 here. So the role, we have role and system, right? So you are a hardware monitor, and then the user, this is what I'm saying. The user's computer has the following statistics explain the computer's health, right? And RAM info is that pointer here. So it invokes this function, returns this string, right? And we built this in one of the previous videos that I've done. Right, before I got my Nano, I was experimenting with things on my desktop. It's like a 15-year-old desktop, which is why I used Quinn, is because it's a lot smaller. So we developed this, right? The role is like who you are and the system. So now it's me, the system, saying to the Nano, you are a literal hardware monitor. Do not calculate new numbers, only use the numbers provided in the user prompt. Be extremely concise. That's like kind of like the rules that I'm giving it. And then the user, like this is what the user is saying. So this is what the LLM is trying to respond to. The user's computer has the following RAM statistics, and then I return that string right there and put it there. Explain the computer's health, right? And then I send that here to Quinn using Ollama, and then I print the message and the content, right? Okay, so system RAM usage is normal, 10% of total. Okay, awesome. So it ran. That's the important thing, is we got our Python to run in the Nano. Now we can start, playing with things and seeing how we can make it a little bit more complex. Okay. So, yeah, I have example 1, example 2, example 3 here. and we were kind of going around and messing with these things to try to understand how do we actually build things. So let's actually just create a new file, right? Let's just say Jetson example 1.py. Okay, let's just do this. And now we're going to start this from scratch. So what do we want to do? We want to import Ollama, right? And we also want to disable Copilot. There we go. And we want to now I know that we need the messages, right? Okay, so we can have the tools. So let's do a tool. So def my tool number 1 is going to be, and this should be descriptive. We'll change it later. So my tool number 1 is going to be return. I don't know. What is this tool going to be doing? It's going to return. Okay, so status of lights. Okay. All lights are currently on. Okay. So this is going to be like if the Jetson is trying to understand what the world around it is like, and it has something called status of lights in room. Okay. So now what I want to do is come in here and create the messages is equal to a list, and this is going to be a JSON, right? And I am going to say role here is equal to system. Okay, and we need to figure out what are the different roles that we can take on, because there's system, there's admin, or there's all sorts of system or like roles that we can take on. And then what was it, like command or something, or prompt? What did we call it? Content. Okay, content. Content here is going to be equal to you are an AI assistant and have access to okay, so I want to tell it how to. Now I'm thinking I should have been developing this on the actual Jetson and not here, and then I should have just copied it back over. Okay, whatever, it doesn't matter. Okay, so you're an AI assistant and have access to the status of lights in room function. Was it something like this? Let me look at the example. So, okay, available tools. All right, so we have system and then content here. And then all of this. Okay. You are an agent that can request tools when needed. Okay. You are an AI assistant. Yeah, I like that. That can request tools when needed. Okay. Right, we need to triple quote this. Okay. There we go. Now I can say available tools. Okay. Is going to be, what is going to be status of lights in room, right? That's the only available tool. And now, how do we give it multiple? Let's try to give it multiple. Def status of a temperature in room, I should say. Temperature in room here. Return whatever 20 degrees Celsius. Okay. And then we'll say here, like, temperature in room. Okay. And then we give a description. Okay. Returns the state of all the lights in the user's room. Okay, this one is going to be returns the temperature of inside the user's room. Inside the user's room. Okay. So now, do we have to tell it how? So you may only request tools from the available tool list. Okay. Never invent new tools. And if you need RAM information, only respond with this. Okay. So now we give it rules. All right. So rules here. Number 1, only use available, or if you say, okay, yeah, you can only request tools from available tool list. I like that. Because I don't want it to go and try to grab a tool that it doesn't have access to, but I also don't want to force it into using a tool, right? So I'm going to say exactly that. You may only request tools. You may only request tools which are provided in the available tools list. Okay, that's rule number 1. Rule number 2. Okay, this is kind of a repeat. And then if you, If no tool is needed, answer normally. If no tool is needed, answer normally. Okay. So that should do it for the system prompt. And then oh, I need to give it the arguments. So I can say request let's see, I can say format is going to be here, right? No, I don't want this. What's the escape character? Okay, we'll figure that out. Did I do it up here? I must have, right? Anyways, well, status of lights. So I want it to request tool, right? And have that be here, right? And then I want it to say args, right? And pass in nothing. Then very similar to that for temperature of room. But now we just put this in. Okay. Temperature of room like this, and so this is messages, and now the second one that I want to do is going to be role, and now this is going to be the user, right? And content is going to be nothing. It's going to be empty because we're going to fill that out. All right, so now we have the messages, and now I want to say while true, okay, user input is equal to input here, and then I want to say ask, or I could just say, right, kind of like this. So I get the user's input, and then I say if user input is equal to quit, or user input is equal to quit, right? Exit. Okay. Now, what else do I want to say? Now I want to append my message. So let's see. I now want to say, that I am going to messages, right? So I'm appending messages here. And I want, so we have 2 items in here, right? So, and this is a list, so I should be able to index it by 1. And then I get a dictionary. And how do you index a dictionary? That is by saying you want content. So this is the key, and I'm going to assign it the value of user input. Okay. And then I want to then what do I want to do? I want to take those messages and put it to Ollama. So response is equal to Ollama dot generate. And what do we need to pass into this? Let's take a peek. Okay. Model and messages. And then we can see message and content. Okay. Look at that. That's beautiful. I'm so... Okay, why did I do that? Okay, so model equals messages equals. So model equals... Wait, is that a... No, it's... Model equals and llama 3 8 billion messages equals messages. Yep. And then we can, so it's going to give us a dictionary, and we can kind of just print response, and then but now we need to check it for a tool, right? So I want to say if response, and now we index it at that. Let's see how it does it, right? So it's going to I want to see what it is. So we get model here. So we're getting a dictionary, right? So this is response. So I want this is a dictionary. So I want key value. I want value of what? Response, okay? And response is this long string. So why content? Where is content? I'm not sure. But I know that it was working, so I need to figure that out. Like, what is that? Response is if... Oops. Is equal to... this, then we need to deal with it, right? And then if this is equal to the other one, this, okay. Why was there a thing? Okay. Why are you unhappy? Oh, okay. I thought that it was part of. Okay, so what do we want to do in this situation? We want to say we want to feed this back to the user, right? I believe so. I believe we want to feed it back to the user. So, or feed it back to the model. So it should be something like messages.append, and now I want to append dictionary and say tool. How do we do that? Role is tool. Okay, so yeah, role is tool, and the response is, or the content is going to be equal to this one is this PTR. Okay. Like this. But then this one is not going to be, this one is going to be temperature in room pointer. Okay, and now we need these two pointers up here. Okay, and temperature of room pointer is equal to in room, like that. Okay, so now we can invoke them. And after this, I need to do another one, so but now we're gonna have multiple things here, so how to, maybe that's why it was printing off. Maybe we're gonna say like LF, right? And then say else here. Okay. And this one is going to be Ollama dot generate, and we're going to say the same thing, like model is equal to llama 3 8 billion, right? Messages is equal to messages, like that. And then we just print the actual response back. I don't know if I don't think that this, I don't think that I'm getting the right. So should I just override it? Response is equal to llama like that. I don't know. I don't know if this is correct. We will find out, I guess. So let's save this, and then we're gonna keep doing this. Okay. Let me, instead of dealing with the SCP, I don't want to do that actually. I'm just gonna see if I can copy it over. Touch Jetson example 1.py. Okay. And now can I just, is pasting available in Vim? Yeah, it looks like it is. Okay. See if we get a compilation error. Probably. Python 3 Jetson example 1. Oh, we didn't get a compilation error. Hello, can you hear me? Although we haven't done much yet. Let's see if it actually calls the model. Okay, yeah, there we go. Got an unexpected argument messages. Okay. Oh, is it because we want chat? Okay. I am going. Where am I? Here I am. I think maybe it is because we want chat. Okay. Chat. Okay. And obviously right now things are very clunky in terms of, like, I haven't gotten into a rhythm of, okay, this is where I'm developing. I'm developing either on my host or on my Jetson. Here's how I'm transferring over the files. Here's how I'm editing. Here's how, right? It's very clunky right now. Obviously, as we move forward with this project, we'll get more into a groove of how we like to set things up. But as of right now, very clunky. Okay, so now let's, did I right save it? Whoops, that's not fun. There we go. So cat, okay. Did I save it? Yeah, all right. So now, I do this. Oh, that's not what I wanted. I was trying to do the Python one. There we go. This is what I wanted. Okay. Hello, can you hear me? So no error immediately. Okay. But it needs a minute, a full minute, to actually load, because we have a 5-minute like cooldown where the model, the Jetson, it will keep our model, the Llama 3, in RAM for 5 minutes. But if we don't use the model within that 5 minutes, it will flush it out of RAM. So now it's been over 5 minutes, so it needs to reload all of that. Okay. So that's what it's doing. It's reloading. I really wish that I could actually develop on my desktop because it would be so much easier. But I don't have a USB-C to USB-C. I don't even think that this thing accepts a USB-C. Do I have anything that would... maybe. Hold on. I might have something that might be able to help. Okay. This is taking a very long time. Has it been a minute yet? Maybe it's trying to use a tool, so it's doing 2 loads. I don't know. While we do this, let me actually just come here. I'm going to change these. So this is chat. This one is chat. And this one is chat. Okay. So now what I want to do, this one is thinking. I am going to say, what do you... Ooh, we got something. What do you think of my example Python code which I just created? Okay. Can you give me some ideas on how I can improve things? Okay. So we're going to do that there, and now come here. So, all right, it loaded everything. It feels so hot right now. It feels so hot right now. It feels so hot right now. Let's just see what it says. Now, I expect this to take a little bit less time because the model should already be loaded in RAM, but it does need to call things twice, right? Please provide, okay. Okay. Happy to help with that. Let me request a tool to check the temperature in your room. Here's my request. Tools, temperature, all right. So it did this, but I did not. So it gave a long string, right? That's not what I want. I want it only to respond with this. Okay. You have mainly built the industry, what is known in the industry as reasoning and acting loop. You've successfully taught the AI how to ask for help when it doesn't know how to do something. However, as you've noticed, your current code requires a lot of manual string matching. If the AI changes one character in the JSON string, your if statement will fail, which it just did. So yes, here is how you can move from hard-coded to dynamic agentic calling. So tool calling. Ollama Python library now has built-in tool support. Instead of putting instructions in the system prompt and manually parsing strings, you can pass your Python functions directly to Ollama. Python functions directly to Ollama. Why this is better, auto schema. Ollama reads your function name and doc strings to tell AI what it does. Reliability, you don't need to check for strings. You check for tool call objects. Okay. So here's a refined version of your script using the official Tools API. I also added streaming and memory management so the agent feels more alive. Okay. So we do this, right? We do this. This is actually what we wrote in our like system prompt. Pure smart home assistant. Okay. Available functions is going to be a dictionary of key value pairs. Okay. And then we append role is user, right? And their content is the input. Yeah. And then we just add tools in there. Okay. Check if the AI wants to use a tool. Right. So for tool in if message dot or response here dot message tool calls. Okay, so follow-up question number 1 is what actually does Ollama chat respond with? I guess I could try it here, right? I could do a quit. Right, there we go. I could try a curl command. I did it a while ago. Here. Then I need model and prompt. So I want to see chat right there, and I want to say model is equal to llama 3 8 billion is equal to something, and then what was it? Streaming is false. Something like this. Prompt, hello, can me now. Okay. Oh, right. Okay. So it did not immediately fail, which means I think we got generally the right format there. We'll see what it responds with so that we get an idea of what the response is, okay? So role tool it's still not going. So inside of here, okay. So we get a dictionary and it says models here, right? And we want message. Okay, so message is a dictionary, which is why we need to do that. And we are looking for content, but content is nothing. Okay. So I'm going to say what am I even trying to do? I didn't know that you could use the dot notation for dictionaries. Interesting. Tool calling. So I'm gonna say here to my original Python script, here is what it responded with. What do you think the problem is? Okay, like that. And now for this one, I want to say I'm not seeing anything that says tool. I tried to curl a command to see what chat responds with, but I don't see any field of tool calls. And also the message is empty. Was it message or was it content? The content is empty. Okay. Do we have more questions about this? So for tool, okay, thinking, I need to use tool name. So this is printed to the user, okay? And then function to call is available functions. Okay, that makes sense. And then tool function, this is the response, right? Function name. Okay. Messages.append, and now we append the message. Okay. Here. Roll. So we're just going to keep appending the message. Roll tool content here. So get the final natural response from the AI. So follow-up question number 3 is, so we are going to keep adding messages to the array. How does the LLM know which thing to respond to? Okay. Number 4 is going to be and what is messages eventually going to start looking like? Okay. Question number 4 is, what if the model needs to keep using a tool before they can respond back to the user. Although maybe this one is more advanced and we're gonna have to do this in the future, not right now. Okay. Okay, if you hit enter 2 times, it will do it. Okay. So what does Ollama chat actually respond with? Your curl result shows why the Python library is so helpful. Okay, so library versus, again, the Ollama like wrapper that I use in the terminal, and then the Python library, these are different things. So I can't rely on one, I think, to determine the other. When you use curl, Ollama expects messages array here since you responded with prompt, which, oh, I see, okay. So I should have used prompt when I did this. Let me do this again. And instead of prompt, I am going to say messages. Okay. And then this should be an array. All right. Hopefully it hasn't been 5 minutes, and we'll see. What did I do? Okay. Model is Llama 3, 8 billion here, and messages. Okay. And it does not. Streaming is false. Okay. There we go. Okay. So now we'll see what it says. In Python library, Ollama library doesn't return a standard dictionary. It returns a class object. Okay, so that's why we're able to use the dot notation. I was like, wait, what is going on there? The old way is this. Okay, fine. The new way is just using the dot notation. Got it. Okay, tools field only appears if the model you are using supports tool calling. So Llama 3. Okay. You pass a tool. Okay. If you don't send a list of tools, the model won't even try to look for them. Okay. So, yeah, the chatty agent problem. In your manual, here we go, we got something back. Content is still nothing. Awesome. Okay. So in my script, the AI said, let me respond to a tool here. The problem, the AI talked its internal thought out loud. In a real agent system, we want the AI to only output the JSON when it needs a tool so our code can catch it. Model choice. the standard, this one, wasn't officially trained for tools. It tries to act like it's calling a tool by typing it out. Switch to, okay. These models are fine-tuned to stop talking and just do it. Okay. What does the messages array look like? Okay, so follow-up question number 1 is, how would I free up the memory for the Llama 3, which I already pulled the manifest for, if I want to now switch over to Llama, what was it, 3.1 or Llama 3.2. Follow-up question number 2 is, which one would be better? I see that 3.1 has a higher parameter count, but 3.2 sounds like it would be the newer model. Okay. So what does messages array look like? The LLM, and then I need to give this, right? It is still not acting in the way I am expecting. Okay. So what does messages array look like? The LLM doesn't know which messages is the latest. It simply reads the entire array from top to bottom. Every single time you hit enter, it treats the very last user message as the current command. Okay, I see. So it's just the last user command. As the conversation continues, your messages array will look like a script. Okay. System. You are a useful assistant. User, hello. Assistant, hi there. User, okay. Assistant. Tool call, okay, not shown to the user. Here, okay, and we're adding all of this to that message list. Okay, how it responds to the right thing, because the assistant roles and tool roles provide context, the LLM sees the user just asked a question at the very end of the script and uses the preceding tool data to answer it. Okay, so question number 4 is going to be, I see user assistant system as roles. Is this just a name that I can create myself, or is it a standard string which is enforced by Ollama? What are other roles which I can use? Okay. Multi-step toolchain. You asked, what if the model needs to keep using a tool? This is called multi-turn reasoning. User, is it safe to go outside? AI thinks. Okay, here's another follow-up question. Like, I have seen a model think. In this context, I was not on a web-based, on a web chat, on a web interface, I was directly using Ollama. I had not... How does was the thinking actually happening inside of the LLM, or was Ollama doing some abstraction? Ollama, I believe I was doing run deep seek. I think I was doing deep seek. Was Ollama doing abstractions for thinking? Okay. Wait, is it raining outside? Get weather condition. No, it's freezing and stormy. Okay, to put this inside of a while loop, as long as this is not empty. Okay, so then you just need to keep getting. Okay. Try upgrading to 3.1 on your Jetson. Run Ollama pull this. Then change the script. You'll notice it becomes much quieter and more precise. Okay. So let's do these, and then we'll try to fit in how we're able to actually hit or get the upgraded version, and then start improving things more. Okay. So freeing up memory, Ollama keeps a model in your RAM for 5 minutes. But what about my micro SD card, right? If you want to force it out of memory to make room for a new model, you can do keep alive 0. Okay. Stop, Ollama stop, or restart the daemon. Okay. I was kind of meaning in terms of like my SD. I was actually meaning getting rid of Llama 3 from my micro SD card memory. I think I have 128 gigabytes, so it's not terrible, but you know, I'm just playing around trying to understand how everything is working. So we this is more for like in the RAM. For your Jetson Nano, the answer depends on your goals. 3.1, this is smarter and much more reliable at tool calling. It has 8 billion parameters, so it's a tight fit but well run on your 8 gig. This one is newer but smaller. It's extremely fast on your hardware, but it might forget its instructions or hallucinate more often than the 8 bil. So 3.1, okay, 8 bil. The thinking power, okay. Alright, fixing your curl command. Your curl failed for 2 reasons. You wrote messages. Yeah, I guess I did. Okay, the endpoint must have an array of objects with roles. Oh, I see. Okay, fine. But I'm not going to run it again because it's going to take too long. And I actually just want to... Ollama pull, and then Llama 3.1 8 bil. Alright. It's the command. Yeah, 8 bil. We will let this run. It's going to pull its manifest, and we'll let it do its thing. Okay. Yeah. Your curl failed for 2 reasons. Awesome. So roles, user assistant tool. These are the standardized strings. Well, you can put whatever you want in there. The model was specifically trained to treat these 4 differently. Okay, so these are kind of the 4 entities which we can take on, right? So system is going to be inner monologue, sets up the rules, okay? You are a light switch box. The user is the human, okay? Makes sense. Assistant is going to be AI's previous responses, okay? And then tool is going to be, this is the rule that the tools respond back with. Okay. So DeepSeek thinking is the thinking real? So when you see DeepSeek thinking, it's in the terminal, it is actually the model itself, the model talking to itself. So inside the LLM, DeepSeek was trained to output text between thinking tags. It is literally reasoning out loud before it gives you the answer. Okay, so the processing is actually occurring within the DeepSeek LLM, like neural network. Interesting. Ollama just detects those tags and applies cool formatting to it. Okay, yeah, that's what I saw at the formatting thing, and I was like, interesting. Do you know how this thinking actually occurs? What material or publications can I look into to see how this is actually happening inside of the neural net? Okay. We're only at 18%, by the way. Good thing. See, I am getting smarter because a lot of times in the last video, I was talking, and then I came here and did enter, and then I saw, oh, this is going to take like 10 minutes, right? So now I press enter and then come here. Okay. The multi-tool loop. If your model needs to use a tool, then another tool before answering. Your Python code needs a loop, like, so response and then message, okay, and then tool calls. Okay, message append, and then we are going to be appending add the AI's response. So response here dot message. Okay, and now that is going to be, this is an object though, right? But if response dot message is actually an object, how is this a correct thing to store in a list? Because the list is a dictionary, right? Maybe in our previous one up here it isn't anymore, but yeah, it is right there. Okay, the other thing that I'm seeing is that this is kind of getting away in our history. So what I want to do is I want to status, git add, git commit, wrote simple orchestrator for NVIDIA Nano to test functionality of hardware and OS. Currently working. Okay. Okay, now we can freely change this. So let's kind of copy this essentially. So we are now going to be changing things, right? We are going to be saying we're no longer going to be having this messages, right? Oh wait, no, messages is just going to be singular. Okay, so I'm going to go like this and just get rid of this. Die. Okay. Please just stop. Stop. Okay. So now, instead of this messages, why am I doing this? I'm just going to delete it. I am just going to delete it. And now I'm going to say, we're going to get rid of this too. Okay. So we're going to keep these two, right? We're going to keep that. That's fine. Now I want to create a dictionary of my two functions. So available functions, right, is going to be equal to a dictionary, and the key is going to be this, right? Let me just see. Yeah, okay. Like that. And the value is going to be this, and I don't need the, okay. And now I can come here. Okay. Like this. And now like this. Okay. Follow-up question, and this one is more like administrative kind of thing. As I said, like as we continue practicing, we're going to get better and better at finding a groove for how to actually develop. So if I am developing on my MacBook and then have a terminal open for SSH, is there a way to use the CLI to like paste in the contents of my clipboard into a file and overwrite the content currently in there? Essentially, I want to copy the file I have on my Mac and use paste to change the Jetson version of the same file. Yeah. Otherwise, we might just need to use the FileZilla. I don't know. It just seems a little clunky. It seems clunky, doesn't it? Doesn't it? Maybe it doesn't. That's whatever. Okay. All right. So we did this. We got those. I don't know why there's a comma right there. I don't know. And now we need messages. Okay. So we gave the available tools. Awesome. And now I'm going to say messages is equal to, and I'm trying not to look right now. So the first thing that we have is we only have one thing. So we have role, right? And what is the role? This one is going to be system, okay? And content is going to be, now I can look because it's just like whatever. Oh, they're just, no. Oh, system here. You're a smart home assistant. You are a smart home assistant. Okay. Are we good? I think so. So now we have this messages, right? And now we want to say, okay, so while, oops, Copilot came back. You get out of here. We do not want you right now. Okay. I wish that we could just like permanently disable. I really, so when I'm at work, right? We're not allowed, like, I have my Visual Studio Code thing, but I don't have this option to like press this button, okay? And so I can't press the snooze button. And I can't disable Copilot either. And you know, like this like the agentic one, the one where it's kind of more collaborative, that one I like a little bit better. The inline suggestions, they're terrible because you'll be typing and you'll press like the space to have a space, and then it'll be like ting, and like no, that's not what I wanted. Delete all of that. Okay, then try it again. And if you press space, it takes it. If you press enter, it takes it. If you press tab, it takes it. It's like, well, then which is the one that is no? So you have to do like the right arrow and then the left. Oh my goodness. Oh my goodness. I wish that there was just a standard, like, if you press like space or something, it doesn't take it. Like, space should not be auto accept. That's enter. Enter is auto accept. Okay. All right. So while true, while true, we are going to do yeah. So user input, same thing that we did here, right? Okay. User input, yeah. And then we just do the same thing here. I like the way that they're doing it. It's cleaner. So let's do that. So if user input dot lower, right, in, and then q or quit, then we can break. Fine. All right, so now messages. Okay, so we just got user input. Now we want to do messages, and I'm trying not to look again. Append, right? And what do we want to, I'm trying not to look at here, right? Like that. There we go. So I have messages dot append. What am I trying to append? I'm trying to append this user input, right? User input, but I need to, like, this is just a string, right? So I need to put it into the correct object or dictionary. So I need to append a dictionary, right? Where I say role is equal to user, right? And content is equal to user input. I believe this is correct. Let us come here and verify. Role is user, content is user input. There we go. All right, so now what do we want to do? We want to come here and we want to move this over so that we have a little bit more room. That's what we want to do. Okay, and we want to collapse this so we have even more room. There we go. There we go. Okay. So now, while true, we want to do parse the functions directly to the chat, or pass the functions directly to the chat. Okay. Oh, right, and we need to actually change these. We need to have the doc strings, right? Yeah, okay. Let's yeah, so returns the state of all the, I'm just going to copy this because we already wrote this out. I only want to write things out by hand if it has like educational value. So there we go. Okay, cool. So we got the doc strings, right? And now I did the messages, and once again, I'm trying not to look over. So I want to send this over to Ollama. Let me just like, there we go. Okay. So I want to go response is going to be equal to Ollama dot chat model. Nope, it is model is equal to, and now we're doing it different. So llama 3.1 8 bill. Okay. And messages is equal to messages, right? Okay, so we get a oh, and then we need something like tools. So is equal to, I'm guessing we just do available functions. Okay. So I'm just going to assume that that is right, and then we're going to verify later. So, okay. So now what do I want to do? I've gotten a response. I want to check if, so the response is going to be an object. So I know that I need to parse this, right? So like for tool, right? So for tool in what? For tool in response dot, what is the shape of this? Okay, so here, right? And this is chat. I know that it's not a one-to-one, but like, okay, I'm trying to just look at this so that I can think about it. I'm trying to get the message, right? So message is what like the LLM gives back, and then Ollama packages the message and sends me. So messages is what the LLM actually sends me, and that's going to be a dictionary, okay? And then Ollama packages that dictionary but adds extra like metadata. Okay, so that's the response, is the entire thing with the metadata. Message is what the Ollama, or the LLM gives me. Now, this one is going to be a JSON, and it is going to have tools, something like this. And tools maybe is a list. Okay. So I will say, what? I will say I want to invoke the tool, right? So I want to say response, and I think I can override it. I think that this will just evaluate to a static list, right? That's actually a good question. Does it evaluate to a static list? And if it does that actually increase my memory complexity? I never really thought about that before. Interesting. Okay. But we're not thinking about this right now. So response. So for tool in response. Okay. So now I'm going to get a new response. So I'm going to override it. No, but I need to actually call it, right? So I need to call the tool. So what is this going to be? This is a lit, right? So a list of tools. And what is it going to actually respond with? Because we gave it this. Okay. Oh, I don't know. Okay, I'm gonna have to look. I don't know. So let's see what it actually responds with, right? So tools. Oh, we have to give it. Okay, so we did things a little bit incorrectly, but we can fix it. There's no problem. Hold on a second. Available functions. Get room stat. Why did they? Okay. So this is a string? No, what is this? Is it a get room light status? It is the key here, right? But it's also kind of, they're the same thing here. So it could, is it a string? Because it's not encapsulated with quotations. So I'm going to come here and say this. What are we actually passing in here? Is it a string or is it a function pointer? And how is this processed? Okay. So in tool calls, okay, so tool calls is this. This would have to be a standard tool calls. This has to be a standard that is just like Ollama functionality, right? So now, sure, we can print it, right? We can print so that we know that we are calling a tool. So print, and then we'll say thinking I need to use. Okay, and now what are we using? So tool, right? Dot function dot name. Okay. Interesting. So this also brings up something interesting. Tool, whatever tool is, it has a member called function, which has a thing called name. So I'm going to come here and I am going to say from here, can you tell me more about this syntax? Okay. It might just be like, this is a function pointer, or it is a function. I don't really know how Python deals with like function pointers and stuff like that. But then maybe the object, which is function, has a member variable. Maybe this is like whatever function. So I'm getting the object which this belongs to, like the parent. I don't know. And then it has a field called name. I don't know. Anyways, we're going to figure that out. So now what do we want to do? So we want to actually, we have this response, right? And we have the tool. So we need to actually perform this. So we just printed it out that we're going to think about it, okay? And now function to call. To call is going to be equal to, okay, so we are creating, I believe, a function pointer. Okay. Oh, by the way, actually that's kind of cool. Variable. You see this? Previously, I didn't think about, like, how does Python actually create the types? Because when you're in C, you always have to say, like, int something, or like void pointer, or whatever it is, right? But then once I switched over to, well, not switched over, I do both languages now, C and C#. By the way, very different languages. These have nothing in similar. C# is almost like Java, essentially. Nothing like C. Completely different. But in C#, you can just use var for if you want to just declare a variable, and then it infers it based off of what you do the equal sign to. And now, when I come back to Python, I haven't been working with Python for a while now, I see this variable here, and I'm like, oh, connection, just like in C#. I do realize that my my power is about to go down. Okay, so there we go. So function to call is going to be equal to what? Available functions, and then here. So available functions, which is a dictionary, right? Here. And now I am going to do this. So I am going to be coming here, and so this is a dictionary, and I want the key value, right? So this means that I am going to want, so I'm going into tool, okay? So tool dot function dot name, and what is this going to evaluate to? So the tool is what the tool is what the LLM has responded back to me, right? And I'm getting the function name of the tool. So whatever this is, I don't know. And now tool output, so we're getting the response. So tool output is equal to, and then function to call, and then the invocation of that. Okay. And now, so here's another thing is I'm just going to ask, can you tell me how Python deals with functions and function pointers and the invocation of those function pointers. I'm thinking that it's just like, here is the invocation of the function pointer, but I'm not sure if this actually is a function pointer or not, right? Like, I just want to, might as well ask that follow-up question just to be on the safe side, to make sure, like, yeah, okay, I do kind of understand what's going, or make sure that even though I have a general, I think this is how it's working, I want to be sure. Okay. By the way, let's just delete all this. Let's get rid of it. We don't need this anymore. Okay. So function to call here, right? And let's come back to here. Okay, so we now have the tool output. So what do I want to do with this? I want to append my messages, right? So messages dot append, and what am I appending? I am roll. Is it roll or rolls? Roll, singular, okay, is now going to be tool, right? And we are, oh, it does not like this, because we want to append a dictionary like this, and tool is, okay, I was like, wait, why is it giving me that problem? Roll is going to be tool, okay, hold on, here we go, and we are going to say that, okay, so not the, we want to say content. Content is going to be equal to tool output, like this. So we're appending that there, and then we want to send this back to Ollama, right? So Ollama, and then Ollama.chat, okay? Model is equal to llama 3.1 8 bill. Okay, messages is equal to messages, and now do we need this available tools thing? Tools is equal to available functions, and I don't think that this is how we were doing it, right? It has to be a list now. I think we did that wrong. So like when they did it here, it was tools is equal to, and then they gave a list. So I actually just want to ask, like, why can't I do it this way? So I want to ask number 8 is here. Why can't I do available tools this way if I have defined my available tools as the following? Okay, and now let me go and copy my available functions. Oh, available functions is what I called it, whatever. Okay, so available functions, I'm just gonna copy this, right? Okay, so I want to come here and say, okay, yeah, so why can't I do my available functions this way? Or available tools this way, yeah, okay, fine. So now what do I want to do with this? So I've appended this, right? And so now I want to, hold on, let me go and try to not look again. So messages, append, roll tool, content, tool output. So we've appended this over to our messages, and then we send it back to Ollama, right? So now the next thing that I want to do is I want to take the response. So the response, so we're going to keep doing this. I need to append that to my message, right? Oh, wait, because I need to append. I got this response, and this is just calling for a tool, right? So do I need to put this in as a I don't know. So we're just checking like if it's an available tool. So I'm gonna say follow-up question number 9 is I noticed that you did not append the message for the LLM which it asked for the tool. Did you do that on purpose? And if so, why? Okay, so, all right. We do this, and now we added the thing here, okay? All right, and then we get the final response and print it, okay? So now, let me come here, and I want to say, so we get response again, right? And no tools this time. So we're going to keep doing that, right? Maybe I can come like this, okay? And now I say response is equal to this with no tools. Okay. And now I can print this response dot, and now the response is going to be, before we just look at it, let's look at this. The response is going to be this dictionary, and I want message and content. So message and content, right? So what we have here, message content, yes. And then we want to append that. Okay, so then we want to messages.append, and what are we appending? We're appending a JSON of role, which is equal to what was the AI assistant? Is it capitalized? Hold on. Assistant. Wait, are they all capitalized? Hold on. Let's come back up to here. Did they message.response? They're not. This tool, it is not capitalized. Okay. So assistant, I'm just gonna see if this works. Is here content is equal to response dot message dot content. Okay, kind of like this, right? Oh, I know why. I was like, why am I should import the pip or the Ollama into here so that I actually have access to those, like so that my IDE actually knows that, oh, response here is from Ollama, and it is going to have these fields. But anyways, well, we're going to get better and better as time moves on. Follow-up question number 10. All right, we are racking up the follow-up questions. Okay. Here is my final lines. Okay. And then we say, but your ones are different. Okay. The ones that it gave are different. It is going to be like this, right? Here. Can you explain why you did it this way? Why? And also, I don't understand why you appended not as a JSON, but just as a string now. Okay, once again, that doesn't make much sense, right? Okay, so let's come back to here. Do we have we have plenty of follow-up questions right now. Let's just press enter. Oh, do we let's make sure that we finished what we were doing, right? So we did not encapsulate it with the if statement. That's one thing, right? But we did do this, and then the else, and then we printed that. But okay, so let's go through these and see if we're able to get it. So removing models from the disk. So we can do Ollama RM and then Llama 3.8 to actually delete the models and free up space on your microSD or NVMe. So this physically deletes the weights. Another interesting thing, doing too many follow-up questions, but I want to say, is there a way to just like print the weights on it? That's a cool question. I have to do that. Is there a way to just print? Come on. Print the weights of these models. Can I just go cat whichever folder Ollama model is in, and then Llama 3.1 like this, and see the 8 billion parameters. I don't know, that's gonna be a lot. Would another question is will that crash my system? Okay. So how thinking works. Thinking, like in DeepSeek, is a technique called test time compute scaling. I need a piece of paper. I do not want to get my Nano. I need a blank piece of paper. Come on. Okay. Every time I run into a word which I don't understand, Now, obviously, we can do like a follow-up question, but in this specific context, this is more of a general topic that this is a large rabbit hole, so we don't have time to go into it completely, but we are going to go into it in the future. So I'm gonna say like thinking models, okay, and then technique called test time compute scaling. So test time compute scaling. Okay. Awesome. So I'm writing stuff down so that way I actually have something to go back to and be like, yes, we've accomplished this. Yes, we've accomplished this. And that way we're not like losing information or like stumbling upon a very interesting concept, but then losing it and being like, oh, I just lost to time. Which also brings me, like, I remember that there were some interesting things that we did in the last video, but, or like heard about in the last video, but we kind of forgot as well. Let me just see. Okay. J-Top, is there anything that we're like really okay? Proc device nodes. I mean, this is more Linux kind of stuff. Caches. Yeah, we were doing a lot with like yeah. It's gonna be here somewhere. I remember base images. We're gonna get into that as well. Temperature, okay. So we're gonna play around with temperature, VRAM. Okay. Delay loading. I think it was somewhere around here. So delay loading, load duration, small delay. That's kind of okay. I want to be able to use context for like yeah. So it gives us this context, which is just a whole bunch of like numbers, which correspond to the actual token. But I want to figure out how do you use the context to actually make our memory more efficient, because right now we're just storing everything in this message and then just appending it, but we're appending the actual content, right? So the next thing is that I'm going to say is how to use context, right? Yeah, context. I'm just going to call them scalars. Scalars to improve load calculation of message history. Okay, there we go. Good. That was one. Okay. Are there other things that come into here? Performance. There's chat latency, tensor processing units, KV caching. Okay. KV caching. Let us try to do that. So KV caching. CACHING. KV caching. Okay. How to keep it hot. Messages here. Streaming is true. So was there anything else that was just like, oh, that's really interesting? I should write that down because I don't want to lose it. Continuous batching. Okay, and KV caching. Okay, VRAM. Okay, continuous batching. All right. So all of these things right here are things that I want to learn in the future, but obviously we're trying to do the basics right now, and so we need some prerequisite knowledge and understanding and familiarity before we can start looking into these to really understand where they are used, why they are helpful, etc. So, continue continuous batching. Okay, continuous batching. And then we have FileZilla, and this is where we were. Okay. All right. So let's go and start looking at our thing. So how thinking works. So thinking, like in DeepSeek R1, is a technique called test time compute scaling. The mechanism: instead of the model being trained to jump straight to the answer, it is trained via reinforcement learning. So I have never touched reinforcement learning. I have, like, when I was at Oregon State University doing my bachelor's degree, I was playing around with, like, training my own neural net. It was very simple. It was just working on the MNEST data set for handwritten numbers. So I've done a little bit of, like, neural net training, but I've never touched reinforcement learning. I've heard that obviously it's a super interesting, super complex field, and I mean, I want to get into that as well, like look into it at least. So anyways, so it uses reinforcement learning to generate chain of thought first. It is rewarded when it self-corrects or verifies its steps. Okay, so they're using reinforcement learning to give it a reward when it self-corrects things. Publications to read. So we can incentivizing reasoning capabilities in LLMs via reinforcement learning. The definitive paper on the model that you used. Okay, so this one would be a good one, and we can look up these papers later when we're starting to really get into, okay, well, what is chain of thought, right? Right now we're not using it, but in the future when we get these models that actually, once we want to play around with new ideas and, like, figure out, okay, well, how does the model actually work, we might be able to do this. So, lists versus dictionary, the message object. So, the messages list is a list of objects in Python. So, is a list of objects. In Python, a list can hold anything: integers, strings, dictionaries, or custom class objects. Okay, so Ollama chat returns a chat response object. So a chat response object. So that's what this is going to be. Okay. Response.message is an object containing role and content. Okay, so just like we create a role and a content, it being Ollama, the chat object, has a field which is role and a field which is content, or an object, right? An object containing role and content. So these are maybe member variables, which they're string member variables. Okay. When do you do messages.append and then response message? Okay, so you aren't appending to a dictionary. You aren't appending to a dictionary, you're appending the exact object the library created. The library is designed to handle both dictionaries and its own message objects. Okay, so the library, I'm assuming that it's talking about Ollama right there, right? So when you do, oh, come on, what is this? Messages.append. So response message is an object, right? So I'm passing in an object and appending it to this messages list. I'm appending an object to a list, okay? You aren't appending a dictionary. Yeah, I'm appending an object. The exact object the library created. Yes, that's correct. The library, Ollama, is designed to handle both dictionaries and its own objects. So follow-up question number 2 is it valid in Python to have a list which contains both dictionaries and objects scattered within the same list? And if so, is this what we are doing? Is this what we are doing with the messages list and allowing the Ollama library to sort everything out for us? Okay. So we're doing multiple things right now. Well, number one, obviously we are learning about how orchestration works, how these AI models work, how to interact with the LLM, but we are also just trying to figure out the exact kind of syntax that Ollama specifically uses, right? So we're just trying to understand, like, that's more of a just general, like, okay, well, this is how Ollama implements it. But then we're also learning what I'm really interested in is more of the high level, just general, okay, well, this is how LLMs work, this is how AI is working, this is how agentic models work, this is how orchestration works, this is what context window, right? So those higher level concepts, but we also need to learn the specifics of, okay, well, Ollama implements it this way, but other orchestration tools might implement it a different way. That's more of a here or there kind of thing. But the main thing is, okay, well, we need to yes, learn how Ollama does it so that we can learn the general. Okay. So you aren't appending a dictionary. You're appending the exact object you created. The library is designed to handle both dictionaries and its own message objects. That's why I'm just doing this to be like, I just want to verify that everything's correct. If you want to move quickly, overwrite a file on your Jetson with what's on your Mac. Copy the code and then use cat. So I can cat and then do that. Okay. Paste. Okay. Press Control D to signal into file. This will overwrite. Okay. Let's actually just try that. So I don't know if this is going to run. We haven't even tried. But let's do this little cat method. Okay, so cat here, and now example, or Jetson, right? Jetson example 1, okay, there. Command V. That's not what I wanted. I want to copy all of this. Command A, copy. Okay. from here, Command V, there we go. Okay, and now Control D. So Command D. Control D. Okay. Oh, I did Control C. That should not be the correct one. Now I have this. What's... Oh, because I did Command D. Okay. Number 3. I am... So on my MacBook terminal, I accidentally did Command plus D, which now split up my terminal. How do I undo this? Okay. That's annoying. Okay. Oh, this is kind of cool. Homebrew, clear, dark. Oh. Can I just... Interesting. What? Okay. Anyways, so let's do the same thing, right? Cat here. And now I want to do Command V, okay, and then Control D. Okay, there we go. So now I should be able to cat Jetson example, and it should be the new one, right? Which it looks like it is, yeah. So now, this is just a Linux thing. But I want to also develop as a Linux developer, right? Get my understanding of all of this. Can you explain more about how the Linux works in the context of this? Okay. Awesome. So parsing function pointers here. When you do tools, get room temperature, you are passing a function reference, often called a pointer. Okay. I'm going to call it a function pointer. Question number 5. Is there any differences between a function reference in Python and a normal function pointer in C? Now, C# is really weird because you don't have function pointers. You don't have pointers, except you can have pointers if you specify like unsafe. C#, right? So C#, you can have pointers. You're not supposed to, but you can if you like specify unsafe within your function or method. And the normal way that you're supposed to do it is through delegates, right? So let's see. Can you go over how Python, C, and C# will use function references, function pointers, and delegates. Okay. You're passing a function reference. Without parentheses here refers to the body of the code. Ollama library looks at this, extracts the name, and doc strings. Okay, so we're getting the actual... This is not a memory address, right? So... Number 6, this would indicate that we are not getting an actual memory address, but it is the entire body? Is it a string of the body characters, or the block of memory which that function occupies? Like, okay, like that. So with parentheses, executes the code immediately and passes the result. Okay. So why your dictionary failed? Available functions here. Error, you executed it. Available, did I do that? Available functions. Ah! Yes, yeah. Okay, available functions. You passed the result of the function to the dictionary, not the function itself. You passed the result. Oh, okay. It should be here with no parentheses. Yeah. Syntax and invocation. So tool, name function. This is an attribute access. Attribute access. Tool is an object. Okay. It has a function object inside of it, which has a name attribute. Okay, a lot of okay. What are we even on? We're on 7 now? Okay. I have not heard of, and by the way, this is another good thing about projects, is you just like run into things that are maybe would be considered basic, right? But you just by happenstance haven't ran into them. So then you run into all of these things and you grow as a competent like developer. So anyways, I have not heard of attribute access before. Can you tell me more about it? And so tool is an object, okay, and then it has a function. It has an object inside of it, so it has another object which has a name attribute. So it has a string, okay? Invocation. Can you show me in Python how an example of this? Not just the invocation of the attribute, but the actual object itself and the nested objects. Okay, like that. Okay, so now, so invocation. In Python, you can store a function in a variable. So I am get room temperature is equal to here, right? So now what this does is print my pointer. So I can invoke this, right? Okay. Tells Python, go to the address and run the code. So it is the address. It is the address of it. But that makes it sound like it is the address. So, right? So, but then when you say this it sounds like in Python, it is the address where the function lives. Okay, so now in my code, I append this whole object directly. Why? Because the AI asks for a tool. Because when the AI asks for a tool, its content is actually empty. Okay, the content is empty, but it has a hidden tools field. If you only save content, which is this, the AI forgets it ever asked for a tool and the conversation will break. Ooh, interesting. Okay. So when we come here, we get the tool. And now I do want to append this, right? Because this is the tool's response. So we still want that. Okay. You must keep the assistance request for a tool in the history so that when the tool result comes next, the model understands that the result is answering. So, let's see. You must keep the assistance request for a tool in the history. Did we do that though? I don't think we did that. So I am going to say down here, I'm going to say question number 8 is going to be, paste that in here, and then I will say this. I'll say paste. So does that mean that my implementation is not quite correct? Okay. There we go. Let us generate that and let's see what we get. All right. Have a sip of coffee. Okay. So, the short answer is yes, but you shouldn't. Okay. Llama stores here models blobs. These files use gguf or safe tensor files, basically giant binary blobs of floating point numbers, the weights. Okay? Will it crash? CADing 5 gigabytes will try to dump 5 billion characters of garbage into your terminal. It won't crash, but your Linux kernel will lock up your terminal session as it struggles to render the random binary data. Oh, okay. The better way, use Ollama show and then model file to see metadata, or use a tool like here if you really want to see the raw bytes. Okay, interesting. Okay, fine. So mixed lists in Python, yes, it's perfectly about. Okay, there we go. Python is dynamically typed. A list is essentially a list of pointers to objects in memory. Okay? Is essentially a list to pointers in memory. One pointer can go to a dictionary. A list is essentially a list of pointers. Oh, so they're just pointers, and they point to objects. Oh, okay. That makes sense. That's what. Then that makes a lot of sense. But then, okay, so I'm coming from it from the very C perspective, where you have an array, and this array is whatever it is, right? It is. Each element is 4 bytes if it's an integer, right? And so then you can index the next one, and that's going to be 4 bytes over, 4 bytes over, 4 bytes over. But in this case, it would be a pointer, and now a pointer is going to be a memory address, and that will be whatever. So you can index over and over and over, and then whatever you find there, you just find there. So whatever that pointer points to, well, then that's what you find. Okay. Next thing is one pointer, and the next can go to here. So The Ollama library is designed to be forgiving. It checks each item in the list. If it is a dictionary, it'll use it. If it is one of my own message objects, I'll extract it for the data. Extract the data from it. Okay. Here, to undo, Shift Command D. So let's do that. So Shift Command D gets back to here. Okay. Okay, there we go. So, or exit. Okay. This is redirect operator. Okay, so that's what it's called, redirect operator. Cat normally reads from your keyboard and prints to the screen, right? Does it? Right? Because I do cat and then a file. Reads from my keyboard and prints to the screen. Okay. The arrow tells Linux, take whatever you would have gone to the screen and shove it in this file instead, okay? Danger, we'll delete everything in there. So take the output and put it in there. So cat, but if you just do cat by itself, what does that do? Reads from the keyboard, right? Reads what from the keyboard? A file name, right? Because it seems opposite. Like normally when you do cat, it gives you the file. Okay, 5, 6, 7 pointers versus references. Okay, so differ significantly in how they handle memory. Okay, so C, you have function pointers, a literal memory address. It points directly to the first instruction of the machine code. Yeah. Delegates is an object that wraps a function pointer. It's type safe. By the way, that's what I was talking about when you have to say unsafe, right? It knows the signature, meaning the arguments and return types, and won't let you call it wrong, incorrectly. So in Python, function reference is an object in the heap. It contains bytecode. Okay, instructions, docs. Okay. So body versus address. In Python, here is a reference to an object. Okay. It's not a string of characters. It's not a memory address, okay? Though it has one. Okay, so a function object, when Ollama looks at get room temperature, when Ollama looks at this, it uses introspection. So is this... We're going down a lot of different rabbit holes right now. Introspection, is this... This is when the code looks at itself to identify the like objects of it. I think it was very similar to like I think introspection is used in dependency injection, if I am correct. All right, so attribute access here. This is a fancy name for using the dot to get inside of an object. Okay, so classroom here. Okay, so let's look at this. How long has this video been going? Do I have enough memory? I don't know if my MacBook is... My MacBook is always, it doesn't have a lot of memory, so I'm always cautious of like, am I gonna crash my system? I might need to end the video and then just keep on going. Okay, so attribute is just a fancy name for using the dot to get inside of an object. Okay, so room, we have init, right? And self, yes. And then I instantiate an object and I get that object, right? And then I can do this, right? Or here. But I was hoping for it to show me in regards to this. I wanted to see how it uses this to get that. Anyways, you noticed I did this while you did a manual dictionary. Why my way is better for agents. When the AI wants to use a tool, this looks internally, okay? If you manually do this, you are dropping the tool calls. The next time you talk to the AI, it sees a tool result in history, but no assistant question attached to it. It's like seeing an answer to a question you don't remember asking. Okay, so what I think I'm going to do, I'm a little bit worried about this video like crashing my system. I am going to end the video right here, and then we're just going to roll right into the next video. So if that is interesting, subscribe to this channel. We are going to keep going on this project, and we're going to keep moving forward. This is super exciting. I'm super like, yeah, this is awesome. I'm loving this. So subscribe. Thank you for watching. My name is Timothy Lee Grant, and I'll see you guys in the next video coming right up.